Today we have another wonderful webinar, and I am proud to have one of our esteemed members, Todd Sutton, with Zachary. He is also one of our executive committee members and leaders within CII. He has worked closely with our presenter today, so he is going to go ahead and introduce our presenter. Todd, take it away.
Thank you, Jenny. So today I'm privileged to introduce our speaker for today, Dr. Bing Han. He's an accomplished scholar and assistant professor in the Department of Civil Engineering at the University of Colorado, Denver. Dr. Han is an authority of integrating emerging technologies and especially around modeling and into the construction industry with an unyielding commitment to pushing the boundaries of what's possible. Having worked alongside Dr. Han on the groundbreaking CII research project on virtual reality in construction a couple of years ago, and also he had me participate in a research project for the Texas Futures VR experience that was part of the Planet Texas 2050 UT Grand Challenge. I've witnessed firsthand his exceptional insight and innovative approach. And he was awarded in 2022, he was award recipient for the CII Outstanding Student Award. Today, he'll be sharing with us the fruits of that labor and dedication. And now I'll turn it over to Dr. Han.
Thank you very much, Todd. That's very generous. Hi, everyone. Thank you very much for joining me in this webinar. My name is Bing Han, assistant professor at University of Colorado, Denver. First, great thanks to Jenny, Todd, Daniel, and CII. It's really an honor to be here and present my work. So today I want to talk about pinpointing the real value of VR and AR in construction. I work closely with VR and AR. But first I want to launch a quick poll to see the audience. Thank you, Jenny. Yeah. To see your current experience with VR, AR, MR, these technologies. I would appreciate if you give me a feedback on that so I can adjust what the content I'm preparing.
And everyone, I forgot to mention that we will take Q&A at the very end of our session today. I'll mention this while you guys are submitting your poll responses. So there is a control panel on the right-hand side of my screen. I'm not sure about yours, but you'll see a little gray box called questions. And if you expand that by clicking on the box with the arrow, you can submit a question and Dr. Han will address it at the end. So Bing, I'm not sure if you're able to see the results. Can you?
I cannot see it for now. I guess if you close it, I'll be able to see it. Or are you seeing the result right now?
Yeah, I think we're 83% have voted, so we'll go ahead and close that poll and let's see if it gives the results.
Thank you.
It did not give the results. I'll go ahead and tell you what it was. It was 7% have not heard about it, 32% kind of know. 36% have played with it at least once. 18% I've used at least one of these in construction, and only 8% have developed VR, AR, MR apps.
Yeah, sounds great. Sounds exactly like. Oh, there it is. Yeah, sounds exactly like what I get from my recent industry survey. So that is very good. Okay. Yeah. Can you? Yeah. That's it. Okay. First, a little bit about myself. I get my bachelor and master in civil engineering from Tongji University in China. After that, I came to US, joined UT Austin, get my PhD in civil engineering at 2022 under the supervision of Dr. Fernanda Lechi. And since then, I become a assistant professor at CU Denver. So my research primarily focused on building lifecycle visualization. I use different type of visualization at different stage of a building environment for simulation, collaboration, optimization, and I use different type of information communication technologies to realize these functions. VR, AR, MR, that is the majority of my current research. Outline for what we are gonna cover today, I'll start with scope, talking about what are these technologies. I see there are several confusions about this in the industry. Next, I'm gonna talk about why do we wanna use these technologies, why you all should care about them. Then how to use them and what are the future directions. So first, definitions. I always like to start with definitions so we have a clear scope of the technology we're talking about. Virtual reality, the key defining characteristic of virtual reality is visual immersion, which means you are either in a cave or you use a head-mounted displays. That technology block your view to the real world. So the only thing you can see is the virtual world. That means it doesn't matter if you do it on the construction site, on your office, in my office, doesn't matter. Whatever you see is the virtual world, and only virtual world matters to you. Augmented reality is the technology that superimpose virtual content onto the real world. So the key idea is overlay. You see both virtual world and real world. Combining the two words, that technology makes sense. And then mixed reality, well, the more confusion is in the mixed reality part. Currently for our industry, the leading definition is more about it is the next step of augmented reality. The app you are using will understand, will have some intelligence to understand the real world, so you can realize the interaction between real world and virtual world. Sometimes you hear about extended reality. That is just an umbrella term that covers all three technologies. Okay. So the key question, the key topic I want to talk about today is why, right? Well, you can see here, I have a photo of all the equipment I have. A great thanks to Fernanda Lichi, my PhD supervisor. I purchased these equipment at the beginning of my PhD. It's like $3,000-$4,000. It's just equipment. They come with cool games you can see here. So why is it related to construction? Why construction professionals should pay attention to this technology? Here are some use cases I summarized. So let me share a video with you.
We've equipped you with your harness.
So this video demonstrates different types of.
You should find where to clip your lanyard
I hope you're
Use the
looking
trigger
at
on your controller
a video playing. Worker is trying to connect himself with fall protection. So you can use virtual reality for training. This is an app I developed myself. It is this is a future construction site. Thank you, Todd, for the model and access. So here you can see I use an iPad to visualize what is going to be built, and that app can be used for on-site visualization, site planning, different type of applications. This is another video, mixed reality. You can see the application understand the surface of real world, and you can use it for on-site pipe routing. This is another good tool for professionals on the construction site. They can recognize the surfaces and do intuitive pipe routing. This is another app I developed myself. You can see this is a building in UT Austin. So using this app, you can visualize from your iPad to see the piping system, what is hidden above the feeling, and then understand understand your to support your maintenance use cases. Let me stop sharing that and bring back my slide. Yeah. So at different stage of construction project, you get different use cases for these technologies, right? I showed you training situations that can happen way before a project. During planning and design, you can use this. You can use virtual reality to realistically visualize what has not been built, to review this model. During construction, you have site planning, you have on-site pipe routing. After construction, during operation maintenance, you can use it to support operation, and you can use it to identify items, the exact location, and therefore help your maintenance. Key characteristics I see from these existing VR, AR, MR technologies. These technologies deliver information in innovative ways that our industry has never experienced. First, you can visualize the model in real scale. It provides you intuitive and realistic understanding about either the model that is going to be constructed or hidden things that you cannot see after construction. It can help us simulate low frequency situations at a hazard-free environment. Let's say construction safe training. Some researchers use it to simulate earthquake, which is definitely a low frequency situation. But that kind of simulation helps people understand how to do evacuation, helps designers design evacuating signals. Also, you can access wherever you want, on-site, off-site, in your home office, during a vacation, if you want. All these type of characteristics provide our industry kind of innovative ways to understand, to communicate, and that can potentially enhance the performance in many use cases. Okay, I know I see a lot of potentially, it should, it might, and I know that is not enough for industry, for companies to invest real money in these technologies and just put their bet on potential. So next, I'm gonna talk about two ways that I'm involved with to identify, to really pinpoint the industry impact, to quantify the value of these technologies. The first one is performance research. So this is a CII research project. I worked in this project with Todd 2018, 2019. So the idea of this project is to understand if VR really gives us performance improvements in construction design review. So what we did was that we used this building information model of a gasoline refinery facility. We created two identical test beds. The two test beds use the same model. They have the same function. The only difference is that one test bed is in VR, as you can see here. The other test bed use a computer monitor. We invited 24 experts and 24 novices. We randomly assigned them into either VR group or the computer monitor group. And we asked them to perform 4 design review tasks, and we see if the VR group has any improvement at all. In the first task, we asked them to identify design errors in the model. We added 10 design errors manually to the model. So as you can see here, after pipe rerouting, the original support is not high enough. This one, you miss a support here. After rerouting, you have redundancies here. So we ask the users to use the two different type of technologies using the same functions to identify these errors. And the result is that both novices and experts performed significantly better in VR than in their computer than the computer test bed. Another the second use case we ask we use the advanced work packaging developed by CII to separate this model into 9 work packages. And then we want to test the user's understanding on the spatial relationships between these packages. So we ask them to come up with construction schedules of these packages. Can they be done at the same time? Who should be first? Questions like that. Still, result shows us that both novices and experts committed significantly less errors in their schedule, which we believe that indicates they have a better understanding of spatial relationships among these work packages. We ask them to do other tasks. We ask them to identify leftover objects. Everybody did the same. We ask them to memorize the scope of work within this model. Well, no significant difference. We didn't find any significant influence, and honestly, desktop users performed a little bit better than VR users. Sorry. Okay. Key findings we get from this project. First, we quantified the benefits in a construction design review scenario. The benefits you can expect is from 18% to 59% of user performance. But we also see that this is a great hammer. It has perfectly fitting nails, but it is not a hammer that fits all nails, which means these technologies, they are not a solution for everything. They are only useful for specific use cases. Other researchers in academia use similar ways to identify these use cases that are appropriate for VR, AR technologies, including design review and coordination, different types of training and behavioral simulation, mechanical, electrical, and plumbing, quality assurance and quality control. Also, during operation, different maintenance use cases. Site management is also a great scenario for VR, AR technologies. So this finding is published. I published it with my PhD supervisor at 2021. It was published in Journal of Construction Engineering and Management. I put the link here if you're interested in that. Feel free to refer to that paper. In the beginning of my PhD, the majority of this type of industry impact exploration goes to this purely research side. We use these different, we create these different scenarios to test if people's performance. But nowadays, with more and more construction company already using this technology, or at least implement this technology in pilot studies, we after I joined CU Denver, I put together an industry survey with Dr. Caroline Clevenger here. We asked 100. We asked a lot of industry professionals and get 159 respondents from the industry to talking about what it feels like to implement AR/MR technology in industry projects. So first, you can see here they reported the project budget that AR/MR technology are implemented. So as you can see, before $70 million, well, about almost half of the project is below 70%. But below 70 million. But if the project budget go above 70 million, you can see 72% of the project tried to use this technology. We asked VR, AR, MR users about where do you see the benefit of this technology when you actually implement it. And a very interesting result we get is that the top ranking benefits comes with business innovation. So that reminds me of the beginning of BIM implementation when we refer to some of the BIM application as Hollywood BIM, which means it is just a 3D model that's used to either demonstrate the design or communicate with the owner. At least it is a way that designers, contractors showing muscle to say, hey, we are very good at technology, but instead they're not using it in any engineering way. So so the result really remind me of that Hollywood BIM, which means AR, MR technologies, although they are technologically more mature, their implementation in our industry is still at a very early age, where it is used as a communication tool, as demonstration tool. But I also want to mention that we still get quality improvements, improving decision making and planning. A lot of these things ranked pretty high, which means even in the early stage of this technology, we are already reaping benefit from implementing them. Another interesting finding from the industry survey we just conducted is that is about the how mature this technology is. So we get about 50-50 of VR, AR, MR users and non-users, and the result is that AR, MR users ranked the readiness of every aspect of this technology higher than non-AR, MR users. That is, well, you can see the average ranking, the average grading is not very high, which again indicates that this technology is not that mature. This technology is still at an early stage of implementation. But the fact that all users ranked the readiness higher than non-users tell us that we really need workshops, demonstrations for this technology, for non-users to know that the technology is actually better than you expect. It already has the ability to reap benefits, even though you are gonna need some investment in the beginning. Okay. I hope that is solid enough explanation on why should we use this technology in our industry. And the next step, I'm gonna talk about how to use them in our industry. Currently, I see two different routes. The first one is directly purchasing off-the-shelf solutions. There are different kind of, you can see, I just get a screenshot from this tech company's website. You can see here we have VR, augmented or mixed reality. These companies, they provide combined hardware and software. I would say their products are more robust because they experience a more debugging process, and most of them have available tech support. So for companies that only want to explore, okay, what is this? Is this really useful? Can I trust this webinar? For companies who have these questions, off-the-shelf solutions might be an easy choice. You directly buy it. A lot of the process is automated. You upload a model, they will give you the experience. And whenever there is an error, you just report to their tech support. Limitation of these type of solutions, normally they only support one type of use cases, right? If you have a building during design, you want to do VR design review during construction, you want to do AR-based quality control. Well, you need to buy two softwares because normally they support one specific use case, and then you get limited customization options. Even though you know programming, even though you know how to optimize your models, you don't really have these options. And their business model is not very stable, which means maybe this year they are free, next year they're charging you a serious amount of money. So off-the-shelf solutions, that is one route. The other route, this is what I developed with CII 2019. So the other route is is to build an in-house development team. The team should understand build information models. They should understand basically how to develop, how to transfer the model, how to handle the data, and how to visualize it in either VR, AR, or MR. With this team, you can develop your own app. And I want to refer to the virtual reality implementation guide that our CII team helped put together. Basically, it tells you the fundamental process of how, starting with a building information model, and end up with a VR ready model. So I covered so that implementation guide covered all the data transfer, data optimization process. I put the link here if you're interested in that. Data exchange. If you decide to have an in-house team to help build these applications, data exchange is one of the most challenging things for developing these applications. I want to recommend there are software specific solutions. Like if you decide you're going to use Autodesk and Unity, there is a tool called Unity Reflect. It kind of helps you transfer the model and data. You can always use other different type of data type. FBX is the one I use very frequently. You can use these different data types to do software specific data transfer. There are other more generic data transfer protocols, IFC, different type of protocols. This is this requires more understanding on these protocols, but I would say it's more generic. Let's see, if a general contractor use Autodesk product and a subcontractor use other brand products, you can always integrate them using IFC, but not but still, yeah. If you want more more general solution, you're gonna have to understand the data exchange protocols more. I want to present one of my PhD work, which help us to build multiple applications using the same model. So the current issue about developing an app from scratch is that, let's say you start with a BIM and let's say you want to do VR walkthrough. So you do model transfer for VR walkthrough to computer graphics softwares, you process the model, and then you develop it for VR. However, months later, you get the design updated. You want to use augmented reality to do quality control. So what will happen? Because your original model is not interoperable, you're going to redo this all over again. You're going to do model transfer for AR site planning and optimize it and transfer to XR for development. And what I'm proposing here is that when you have a BIM, you kind of do more generic XR model transfer, which means this model is this model include all the information you're going to need for different types of VR, AR, MR uses, and the information is directly attached to the model. After you get an update on the model, after you want another piece of app, you only process the updated part and combine it with the original model. Then you get then you get the updated model with a new application. So I published how to complete this workflow in automation construction. If you're interested in that, feel free to refer to this paper. Finally, I want to talk about, okay, I have 8 minutes. Finally, I want to talk about future directions about using, developing, and researching VR, AR, MR technologies. The first part is always data interoperability. Currently, there are different software system companies working together to create a pipeline of two-way data exchange. But there are protocols I introduced. IFC is a good one. I like IFC, but it's kind of an ongoing, always ongoing process where you always get missing information. So it's a good tool. It's not perfect. So data interoperability that will help stakeholder collaboration, that will be key future directions. We need more standards for data exchange protocols and modeling methods. Second future directions I want to mention is integrated development platform. So I mentioned the platform that you can use for VR, AR, MR development, but still there are problems with that platform. We need more automation. We need more support for different data source. So how to create an integrated development platform is important. Also, another perspective is that how to make the current off-the-shelf solutions more customizable, which means if you don't want to build an in-house development team, you can still customize the solution you purchase a little bit to meet the requirement of different use cases. That is another future directions. The third one, I want to talk about training. So this is the result I get from the CII research. So we reach out to VR to construction projects that actually implemented VR and see where did you spend all of your investment. So surprisingly, well, my initial thought is that the hardware should be a majority of the investment, but surprisingly, developers' salary is 2/3 of overall investment. Software subscription is 20%. It is still more than hardware. So training and getting the qualified people who can develop or who can at least maintain these VR, AR, MR solutions, that can be key for success in this business. The other two figures, I get this from my industry survey. As you can see, we surveyed with engineers that has a lot of industry experience, but the majority of them have had little to none AR, MR experience. And this is also a funny one. We asked like, what is the biggest challenge that stopped your company from using AR, MR, or what was the biggest challenge when you first implement AR, MR? And you can see the majority of the challenge is lack of skilled stuff. Well, I guess this is reasonable because being able to develop these technologies, you are gonna need good understanding on construction, good understanding on programming, and these game engines you're gonna use, also data structure comes with them. So it's interdisciplinary complex work. And I'm gonna say, because we already talked about this, because the technology is still improving, and in current stage it has already provided our industry benefits. So this is a good future direction. In order to catch this trend, investing on people, hiring or training can be key to success in this business. The last one I want to mention is a guidebook and workflow. So we ask the users and non-users, where do you expect improvements for VR, AR, MR implementation? So you can see 88% of users, 93% of non-users mentioned that we really need process improvement. And I want to refer this situation to the implementation, to the earlier implementation of BEAM. So BEAM is a technology, is a concept that has been taught within the academia for a long time. At year 2008, there are already a lot of research showing that, okay, this is a useful tool. You can use this tool for cost estimating, for scheduling, for clash detection. A lot of research talking about that. But in year 2008, there is an industry survey saying that BEAM implementation is still limited. Even if you have the model, normally you only have one BEAM related application in one project. That number, 10 years later, 2018, my advisor, Dr. Lechi, replicate the same survey and figured out that at year 2018, industry companies use on average 4 different BEAM applications in the same project. Where does this improvement come from? Well, I would say a lot of that comes from BEAM handbook and different types of BEAM execution plan. The first edition of BEAM handbook and BEAM execution plan comes at 2008, 2009, that time. These are the guidelines that not 100% focusing on the research, on the science behind it. Instead, they focus more on how to implement it. What type of team do you need? What type of workflow do you need? How do you change your current workflow, or how do you integrate this technology into your current workflow? So because currently the industry survey shows that we are at the stage of we are at an early stage. The majority of the use is business innovation. I want to mention that that putting together handbooks, guidebooks, and workflows can be really beneficial to implementing these technologies. Okay, quick recap, key takeaways from this webinar. First, why do you want to use these technologies? Why do you even care about this webinar? Because these technologies deliver information in an innovative way that our industry really needs. Second, why is delivering that information in an innovative way that important? Because it actually enhances the performance of our industry professionals. It has been proven by research, by experiments. It has been proven from industry surveys. How to use it? We have competition between off-the-shelf product and in-house development. either way, they have their own advantages and disadvantages. Finally, VR, AR, MR, these technologies in the construction industry, they're still at their early age, but according to the research and survey, we see they have a promising future for solving a lot of long-lasting challenges in our industry. Finally, before question and answer, I want to give a quick advertisement for my lab. So I work on my future research will still in this field. I want to in future research. I want to work on VR case studies. I want to do different type of simulations for unconventional building environments. As you can see here, we have we have buildings constructed on floating pontoons. I'm gonna do AR facilitate. I'm gonna use artificial intelligence to facilitate subcontractors in scheduling, in cost estimating, different type of ideas. I hope they are great ideas. I'm recruiting PhD students. We support part-time PhD, which means you can still do your research with me and still work in the industry. If you see any interesting collaboration, either collaborating on these research topics or students that are interested in PhD in these topics, please feel free to reach out to me. And thank you. That's the webinar, and I'm open to questions you might have.
Thank you. We do indeed have questions. So the first one is, what is the difference between the app you've developed and the Trimble Connect app?
Well, that's a very good question. Trimble Connect app helps you automate some process, so you don't need to manually do all the model transfer. You don't have. They help you automate part of it. But my understanding on this type of automation is that the automation also come with limitations on your on customization. You only rely on the functions that they are going to provide. You only rely on the equipment they tested. Well, the good side is they tested for you. You don't need to experience the time-consuming, sometimes frustrating developing and debugging process. But I think that the more decision-making point is that if the functions they are providing matches with what you want to do. I hope that answers the question.
Fair enough. Yes, sir. Okay, our next question is, can you combine AutoCAD drawings with on-location camera to visualize placement of HVAC, piping, plumbing, etc.?
Well, yes. Well, let's see. I'm more. I know I shouldn't take sides, but I'm more in the self-development. My experience is more with self-development. If you want to superimpose AutoCAD drawings on top of the construction site, yes, you can do that. You can self-programming it as long as you can self-programming it. You're gonna need to solve the problem about how to do localization so the app understand where you are. So the location of your 2D drawing is precise. And yes, after that, I think that should be not so complicated development. Also, I know there are I think XYZ kind of develop these type of apps already. I know they do 3D models. I know they visualize 3D models. I don't know if they support 2D drawings.
Okay, wonderful. We do have a request, which I'll go ahead and send the link later to those who participated, but somebody has asked for the link that appeared in your presentation. I believe it was around slide 39 or 40. She had asked if you could paste it in the chat, and I'm not sure if you can do that when you're live in presentation mode, but I will certainly circle back with Carrie to provide that.
38, this one?
I believe so. Yeah, I don't know if you have the ability to drop that in the chat here. Meanwhile, we have a very long question. I'll start reading. How can we meld the technological skill set for development of XR BIM with the experience in actual construction? We've already seen within the PMIS application industry that the divergence from the programmers with the users has truly made available offerings being less than useful out of the box, which frustrates users when they are hit with higher than anticipated costs to customize the app. Is this something that can be integrated into the engineering curriculum?
Well, that's a very good, very interesting question. Is it can we integrate it into engineering curriculum? The answer is yes. We at CU Denver, we are still we started to working on that, integrating VR AR development into an advanced BIM class. We're still working on that, but I would say BIM is kind of the foundation of all these, right? You want to either visualize or superimpose a virtual environment. The virtual environment should, the majority of the time, they come from building information models. So yes, we are having that efforts here, and I believe at UT Austin we don't have a dedicated engineering course on that, but I learned that from School of Information.
Okay.
So another thing I want to add is that we do see if it is self-development, and sometimes we do see frustrating the things you develop is not matching what you want, or does not perform as well as the company want. But still, so one of the easy solutions is to purchase whatever is there, and second, the majority of that is dependent on the ability of the development team. That's why I mentioned the training part here. My personal understanding on this is that you cannot just hand this to computer science and say, hey, develop this to me. Majority of the time it will fail because they don't really know what you want, what is really needed on the construction site. So so if you want to develop, I mentioned that I really hope that it's an interdisciplinary work, that at least people, professionals, civil engineering students that understand the situation, understand what is needed, is part of the development team. I think that is important.
Wonderful. Okay, what tools are you using to extract model objects from a larger model?
That's another good question. I guess the question should come from people who already use it, who is using the software. So let me go through. So here you see my virtual reality model that is only part of the a larger gasoline refinery facility. We select this. The model was in Autodesk Navisworks. We select this part just by clicking all the relevant components within this section. Because the original model is too big and we cannot efficiently visualize the whole model in a VR environment, so we choose to do it section by section. And how to select section is really determined on your engineering knowledge about all the relevant pieces of this section. And then I kind of manually select, okay, these are the sections relevant to my area of interest, and then select all the objects. I used Navisworks built-in export to FBX to export the model.
Okay, so our next question is, given the development of low cost but complex and graphically rich video game technology, why is the technology base in industry, modeling software and development of the models into interactive simulations so expensive?
I don't. Sorry, I don't quite get the question.
Yeah,
so this.
I think he's saying that given that the development of low cost but complex and graphically rich video game technology, why is this modeling software so expensive?
Oh, why is okay? So I don't really agree with the beginning low cost part. I think developing realistic experience in VR is not in the low cost content creation field, and our survey kind of proved that, because the majority of that goes to developers' salary. I don't think the salary from the survey, I don't think the average salary is as high as gaming development. So that's why I agree. If realistic gaming development is a low cost industry, yeah,
Dr.
there's
Hen,
no reason we are expensive.
The audience agrees. Yeah, the audience agrees. I'm getting more comments that video games are very expensive to develop. AAA games are more than 100 million and up to develop. So yes, I think that they're agreeing with you. Yeah.
And another thing is that VR AR in the beginning, the first wave of VR AR, they are for gaming industry. So a lot of existing software simulations, they are from gaming industry. We use game engines to develop this experience. So I would say the industry, especially construction industry, type of app is not as easy to develop as games. So a lot of functions for gamers, you can directly buy a prefab that others already did, but in our industry, you start from scratch. So you program your own stuff. So it's kind of maybe another reason why it's more expensive and it takes longer to develop this software.
So we do have an interesting question here. Wants to know if you have any recommendations related to, so she's saying we have a lot of Hollywood VR and AR as we had previously with BIM. What should the priority be between developing apps versus acquiring off-the-shelf solutions? What are your recommendations there?
That's a good question. So my recommendation is more in the budget side. For big companies, if you have a lot of money, you can invest on these technologies. I would choose the self-development part. You get absolutely more control over the product you are using, and you get more customization. Eventually you're going to get products that fits your needs better. But maintaining, supporting such a team can be expensive. I guess Todd can tell you more than I do, but I know it's expensive. So I would suggest that in the beginning, purchasing might be a good idea, because you directly get almost a top tier performance of one certain use case where you can test if you like this technology, if it really meets your need, and if you have plans to implement this in the future. And then if you get after that, if that is really the direction you want to go and you get abundant initial investment to get a team like that, I would recommend more in the in-house development route.
Okay. All right, we do have another question. Is internet connection still a challenge at job sites? My experience in Brazil is that we still need very stable and speedy connections, especially in some remote areas of the country. Any advice?
Internet connection for I don't quite follow this question. Do you asking internet connection for these technologies or generally for construction?
Yeah, I'm assuming so. Like, are you finding that internet connection has been a challenge as you're, maybe abroad or in other countries?
Yes. Well, I would agree with that, but it's not something I really have a good answer for. My understanding is that for VR, AR, MR projects, some of them you need internet connection. The more frequently, if you want to communicate with others, if you want to coordinate with another person at the same time in the model, you need great internet connection to be there. But many other use cases, let's see, design review, or let's say there is a clash and you want to visualize what that is. You can work on the model yourself. You definitely need internet connection to get this model to get this software. But when you deploy it, you don't really need you don't really need the connection because it's already loaded in the software. You can pre-download it or things like that.
Yeah, no, that's a good point. Wonderful. Okay, I think we have come to the almost the top of the hour. Dr. Han, thank you very much for your expertise and sharing your information with our audience today. We hope you all have a wonderful day, a wonderful evening, morning, wherever you are around the world. Thank you for tuning into our webinar today, and we hope to see you at the next one. And more importantly, we hope to see you in San Antonio, August 1st and 2nd for the CII annual conference. Thank you, everyone.
Yeah,
Enjoy
thank you.
your day.
Thank you for joining me. Thank you.
Thank you. Thank you, Todd. Thank you, everyone. Enjoy your day.